Lesson 6.2.1, graphing y equals a, sine of b, x minus h plus k. So we're putting all of our transformations together. Unfortunately, in chapter 4, you learned what a phase shift or a horizontal compression was, but we never actually graphed any. And that's an angular frequency. That means we're going to change the period here for our sine and cosine graphs. We're going to begin with problem 6-65. Laurel and Hardy each have a variation of the graph of sine. We want it to have an angular frequency of 3 and a shift of pi over 2 to the right. Laurel thinks it's going to be sine of 3 quantity x minus pi over 2. Hardy thinks it's going to be sine of just 3x minus pi over 2. Who is right? What is the difference between these two equations? How do these changes, or how do these change the graphs? So right off the bat, hopefully we're good enough here to look at what's given to us and see that one of those two gentlemen does not have the correct graphing form of that particular function. However, the other thing we need to take a look at here is if we are looking for an angular frequency of 3 and a shift of pi over 2 units to the right, we need to make sure that this angular frequency here is factored out of the equation. So over here in Hardy's equation, he has the sine of 3x minus pi over 2. If we convert that to graphing form, we need to factor a term of 3 out of both of these. Excuse me, a factor of 3 out of both of these terms. So we're going to have the sine of 3. Okay. Well, 3x divided by 3 is x. Pi over 2 divided by 3 is going to be pi over 6. So Hardy's equation actually has a right shift Hardy's equation actually has a right shift pi over 6, not the desired shift of pi over 2. So you really must be sure here that when we're converting this to graphing form, that our angular frequency is factored out of our variable and our horizontal shift in order to take the graphing shortcuts that you know and love from Algebra 2. Otherwise, our graphing shortcuts don't apply, not that you can't graph them. The graph of y equals sine of x is stretched vertically by a factor of 2, so that's amplitude. Okay. Compressed horizontally by a factor of 3, that's angular frequency, that's b. Shifted up 4, that's k. And shifted to the right, pi, that's h. What is the equation of the result? So we have y equals a times the sine of b x minus h plus k. So substituting everything we know, we're going to have y equals 2 times the sine. Our horizontal compression, or our angular frequency, is 3. X minus right pi, so that's minus pi. And up 4, plus 4. Even though the question doesn't ask, let's graph it. So remember, when we're graphing these types of functions, we need to first determine all parts of our function before we get too far into it. So we had, again, the equation was y equals 2. I'm not sure what's going on here with this. Why I'm so slow here. So we have 2. So, I don't know what's going on. Sorry, gang, but that's just not going to cut it. Why don't we do this? What if I try to do this? Copy, paste that in here. Maybe we'll get a little bit faster. It's already slow enough. Keep getting slower than it already is. Waiting, waiting, waiting. It's unbelievable. I just can't understand how something like this. So remember here, before we actually get started, we need to determine all these parts. Okay, so we already know A. The only thing we're missing here is our period. So remember PB equals 2 pi. So P times 3 equals 2 pi. So our period is going to be 2 pi over 3. Okay, so we're talking about sine graph. First steps here, when you're graphing, again, extra review, label your axes. So our period is 2 pi over 3. So we're looking for something here that's divisible by 3 probably, or that we can find half of real quick and easy. These are in sixes, so let's see, 2 pi over 3 would be pretty good to be here. All right, which would make this pi over 3. It's half of 2 pi over 3. All right, and then this here would be pi. That's how we're going to label our x-axis. Y-axis, we have an amplitude of 2, a vertical shift of 4. So we need to have at least 6 units up and down. So I'm going to count every 2 blocks as 1. Okay, that gives me plenty of space on my y-axis. So once I've determined what units I'm going to count by, I can begin actually graphing it. Where do we start? We start with this vertical shift, up 4. Oops, that's 1, sorry. Not 2, that's 1, 2, 3, 4. So vertical shift of up 4. That's going to be our new x-axis, so to speak. Horizontal shift of right pi. So here we're going to run into that issue that Lexi and Hank always bring up. All right, we're going to stick with what we got right now, and I'm going to show you how to do it the way I didn't show you in class today. So to the right pi puts my new origin right here. It's a sine graph, which means it will touch at the origin. Okay, now that's my first point. But since I have no space to the right of the graph here to finish the graph, I'm going to make this, which point? I'm going to make that my last point. So I'm just going to go backwards in this process and find my first point. How far away is my first point going to be? It's going to be 2 pi over 3s away. Well, if each of these, as Stephen said, black lines are pi over 3, 2 pi over 3s would be 2 of them. So 1, 2. So right here is my first point. So I have my beginning, I have my end. Now for sine, again, remember sine is intercept. All right, it's a 0, it's a max, it's a 0, it's a min, it's a 0. So I have my first 2 zeros, my middle 0 will be right here. And then I'm going to have a max halfway between them. How high is that max going to be? It's going to be 2 high because that's the stretch. So up 2, 1, 2. And then my min will be here, down 2, 1, 2. And there's my curve. Perfect. And I only need 1 full cycle to get full credit. Next I have problem number 68. As soon as the computer gets there, we're waiting. Write the equation of this graph. So here we go. If this is the point we're using, that's a 0. All right, and it's increasing. So what type of equation is it going to be? It's going to be sine. What is the amplitude? So how far up does it rise above, all right, that midpoint there, that middle point? It goes up 2. Okay, let's worry about frequency later.
Pardon the interruption, but we got some weather-related announcements.
Vertical shift here is going to be -3. Down down 3.
Baseball.
Okay. And looks to be right shift here. This is a pi. Okay. So that means we're right pi over 2. Last, we have to figure out our frequency. That's where we're using PB equals 2 pi. So on our graph, we need to figure out what the period is. How long does it take to repeat itself? Okay, so here's pi over 2. Half of it happens till pi. The other half happens till 3 pi over 2, which means our period is pi. So pi b equals 2 pi, which means b equals 2. So y will equal 2 times the sine of 2, x minus pi over 2 minus 3 for down 3. Transform the period into angular frequency and write a sine equation, blah, blah, blah. We already did that. Very good. All right. And again, we're still stressing here 5-point graphing method. How can we use it to graph trig equations? Everything we're doing in this section is graphing trig equations. Next problem here has 2 separate graphs. I would like you to go ahead and take a look at those. Graph each of them, begin the way we've done those first 2 problems. And go ahead and view part B to get the answers of the graphs for those 2 problems.